and welcome to the flipped lesson on how to solve quadratic linear and quadratic systems algebraically with me, Mr. Wykhorst. As you watch this video, please take notes on what you see, write down any questions you may have about the video, and as always, you may rewind and rewatch this video as many times as you need to. What I'm going to teach you how to do today is how to solve the types of systems we've been dealing with in class using algebra instead of a graph. So to get yourself warmed up, pause the video and try to solve the system of equations you see algebraically and press play when you're done. Okay, so let's review how we solve a system of equations like this algebraically. The first equation is 2x plus 3y equals 5, obviously a linear equation, and y equals negative x plus 2, also a linear equation. I know from the past, and so should you, that to solve this, we have two options. We could solve by substitution or by elimination. Since the second equation has y solved for, it'll be easier to use substitution to solve this system. So the way substitution works is, I'm going to take what y is equal to, which is negative x plus 2, and I'm going to substitute it into the first equation where I see y. And what that gives me for that first equation is 2x plus 3 times negative x plus 2 equals 5. And now I have a one-variable equation that I could solve. And what I'm going to do to solve that is I'm going to first distribute the 3 into the negative x plus 2. That gives me 2x minus 3x plus 6 equals 5. Sorry about my 5. Okay? And now I combine the like terms on the left side, giving me negative 1x plus 6 equals 5. Okay, to solve for x, I'm going to subtract 6. So that gives me negative x equals negative 1. And since I just want x and not negative x, I divide both sides by negative 1, giving me x equals positive 1. So, now that I know x is 1, I still have to answer the question. I know the x value, but I need the y value. So the way systems work is, since you're finding a point that satisfies both equations, you can substitute that x value, 1, into either of the two equations, whichever one is easiest for you. I think for the purposes of this question, using y equals negative x plus 2 is the easier equation to figure out y, just because y is already solved for. So all I do is I take that 1 and I put it in where I see x in the equation. So y is equal to negative 1 plus 2. And if I simplify negative 1 plus 2, that gives me 1. So, the answer to my problem here, the solution, is that the lines intersect at the point 1, 1. Okay? So the question is, how does this apply to dealing with quadratics? Well, to solve a system dealing with quadratics, it's actually the same process as dealing with lines. So, if I want to solve a quadratic system algebraically, I'm always going to use the substitution property. Using the elimination property is not really convenient here because you're dealing with two different types of equations, a quadratic and a linear. So, if we follow this four-step process, this is actually pretty easy to do. Right? Step 1, so if I'm looking at this system here, where I have to solve y equals x squared minus x minus 6 and y equals 2x minus 2, I'm first going to make sure that the quadratic equations are in y equals form or another form convenient for substitution. The way substitution works is as long as I have an expression equivalent to something else, I could always switch it out. Now you'll notice both of the equations are set equal to y, which means that technically x squared minus x minus 6 could be set equal to 2x minus 2. So I'm going to set the two x expressions equal to each other. So that's going to give me x squared minus x minus 6 equals 2x minus 2. And now, using whatever method I want, I'm going to solve for x. Now, since I'm dealing with quadratics, I'm going to get it equal to 0 and then try to solve it by factoring if possible. So I'm going to take that 2x and I'm going to move that over, and the negative 2 and move that over. I'm going to do the same thing here. Subtract 2x and add 2. What you do to one side, you do to the other. On the right side, I now have 0 because I've taken everything and moved it to the left. And on the left side, the x squared is left alone. Negative 1x minus 2x is negative 3x. And negative 6 plus 2 is negative 4. So I'm going to try and solve that by factoring. So I ask myself, do I know anything that multiplies to negative 4 that adds up to negative 3? And the answer is yes. I know that if I take negative 4 and positive 1, and I multiply those, I get negative 4. And if I add them, I get negative 3. So I factored it. Now I need to solve for each factor. So the way that we show is by splitting it up. So I set x minus 4 equal to 0, and x plus 1 equal to 0. Okay? And then I solve each factor. Right? The one on the left gives me x equals 4. And the one on the right gives me x equals negative 1. Okay. So you'll notice this is a little different because I got two x values. So that means I am going to get two y values. So what I need to do now is choose either the top equation or the bottom equation to find the y values that correspond with each x. I think it's easier here to use the linear equation y equals 2x minus 2 because it involves less arithmetic when I substitute in. So what I would do to show the work is as follows. I would take the equation y equals 2x minus 2. Okay, and one at a time, substitute in 4 and then negative 1. So the one on the left becomes y equals 2 times 4 minus 2. And that gives me a y value of 6. Which means one of my points of intersection are 4, 6. Okay? And my other point of intersection, using the same equation, would be y equals 2 times negative 1 minus 2. And when I simplify that, it gives me negative 2 minus 2, so y equals negative 4. Which means my other point of intersection is negative 1, negative 4. So, my solutions are 4, 6, and negative 1, negative 4. And that's it. Okay? So, now that you've watched the video, what I would like you to do now is to go on to the WordPress site and fill out the Google Doc to rate your understanding of this lesson. And if you need to at this time, you can go back and rewatch and rewind. Thank you for watching.